Hello, hello, hello again. Hopefully you are enjoying the weekend. At my end is super sunny today, so it's a beautiful weather. I think I'm gonna go out later for a run or something like that. So yeah, this time it's my eighth live stream. And idea here, last time my my network decided to die, so I had to stop unexpectedly, and hopefully today I'll manage to finish what I've started last time. So go through the Rust tutorial and explain all the details in the best possible way. And yeah, I think I'm gonna just finish that today and do nothing else. Maybe I'll go through some other tutorials just briefly, but we'll see with the time. It's always tricky. And yeah, that's more or less it. I'll jump into the tutorial soon. But yeah, please like, share, subscribe if you want to get notified about the content I made. And yeah, let's get started. I'll switch to my desktop view. Yeah, if you have any questions, feel free to put them in the chat. Otherwise, let's get started. So I think we started somewhere around here, but I'll just go quickly back and just repeat, because yeah, you'll learn when you repeat stuff. So yeah, I'll just quickly skim through all of this. So yeah, defining variables. Then variables can have types. Then calling a function, which doesn't work because of the lifetime. Oh no, because of the it's not initialized. Here it's a working example. Underscore stuff. So underscore is when you ignore a variable, or if a variable is unused, then you put underscore up in front of the variable and variable name, and then compiler doesn't complain. That's fine. Working with pairs, that's also fine. Pair types for the pair data, and then here we have I hopefully you can hear me. YouTube says my bitrate is a bit low, but yeah, hopefully it works okay. Okay, returning tuples. Okay, statements can be in multiple lines. That's also pretty common. Print line. Exclamation mark is a macro. This returns 4. You don't have to specify return. Pair brackets, declare scope. Yeah, this is a scope for a variable, for a set of variables. That's also fine. Yeah. If statement, match statement. So yeah, it will, if feeling lucky is true, then 6 will be returned. If no, then false. Then 4. That's also fine. Doing that is also okay. Namespaces, okay. These standard functions and dealing with the namespaces, using everything from a namespace. then a vector, defining a struct, that's also fine. That's a syntax for initializing the rest of the fields. That's also great, super convenient. Okay. That's a specific syntax with let that let pattern can be used in conditions in value. If this is true, then store the value here, and then you can have access to value here, which is super compact way of doing these things. Match, and then the same pattern here, then combination with this, that's also fine for like matching stuff, and then for everything else do this, and then we have structs and implementations. Then that there was the whole thing with these structs and mutability. So if you put a mute here, then you can mutate n traits. This is similar to interfaces in other languages and implementation for these traits. Self is self, uppercase, so camel case. Self is the actual struct, so number, it refers to a number, to the number here. So a copy because I32 implements trait copy, then this is by default copied. If it's not, then if copy is not implemented, then it's move. Then it's moved by default. Also mute. We can mutate, but it has to be declared or defined with mute. Self. What does this doing? Initializing, but self is a reference, then it has to be dereferenced, and then this is the syntax for initializing everything. That's fine. If I'm going too quickly, just ask, and we'll go a bit slower, but I think we should be fine. Then the clone. So yeah, if I understood correctly, I think the clone is let's go back to copy. Actually, copy is not here. I think the clone is actually making another object, and copy says that object should be by default cloned. marker traits like copy have no methods. Yeah. So but you can still use the clone regularly to make copy of an object like here. But by default, if you remove, if .clone would be removed and copy trait is implemented, then this assignment here will actually make a copy of n and assign it to m. Yeah, that's here. These things have they are implemented automatically if you specify this. I don't actually know. I don't understand everything here yet, but yeah, syntax is pretty simple. So for now, let's just live with that. Functions can be generic. Yeah, you can put generic. So you can have different types here. Great. Also, you can put constraints. Display, debug. Yeah, these are slightly different ways of printing stuff. Turbofish syntax. So what's the purpose of that? General functions can be thought of as namespace containing an infinity. Aha. Aha. If you put, do you have that as a, if you call type name function, then this will print the type signature or okay. Okay. Okay, vector is generic. Great. And yeah, what I like about vector here is that it will make it will deduce a type by the first type that is pushed to vector. So in this case, v1 will be a vector of integers, or yeah, 32-bit integers. In other languages, you usually, in C++, you have to specify the type. I mean, or if you, or type can also be deduced, but yeah, it has to be somehow deducible on the initial call, on the in the construction phase. This is actually not. So these are two lines. I think that's different. This is syntactic sugar to just create these vectors with less characters. Okay. Type, option type. Yeah, option type can have value or no value. Unwrap. If there is no value, it's gonna panic. Yeah, that's pretty clear. Yeah, option. This is example of implementation. Match self. If there is some t, then return t. If none, panic. Okay. Lifetimes. a reference have a lifetime, obviously. So variable bindings have a yeah, this is a variable binding and it has a lifetime. Also a reference has a lifetime, so this is a reference and has also it also has a lifetime, and it also depends, I think the lifetime depends on X in this case as well. The lifetime of a reference cannot exceed the lifetime of a variable binding it borrows. Yeah, so this code is tricky here because X is created here and then we reference X, but at this stage here, this scope is done and X does not exist anymore. And then it's a problem because xref is not valid. So yeah, that's not okay. You can borrow immutable borrowed multiple times. That's also fine because you're gonna just read from that. While borrowed, a variable binding cannot be mutated. So yeah, so since this is mutable, but we have a immutable reference here, we can't mutate here. While mutable borrowed can be mutable borrowed. If we hold a reference immutable ref, I'm a bit confused with borrowed and referencing. I should probably read a bit more about that, but okay. Maybe I'm saying something wrong, but yeah, in any case, if you have a reference here to X, and then if you try to make another reference which will be mutable, it's not gonna fly because you're already holding immutable reference to that same variable. References in function arguments also have lifetimes. Yep. Sorry. Functions with reference. Yeah, this part was a bit confusing to me. We stopped somewhere here, and this was a bit confusing. But let's try again this time. Functions with reference arguments can be called with borrows that have different lifetimes. Okay. This is important piece, I think. Lifetimes are generic parameters. So when you put a tick here, here, then you specify a lifetime. This is a named lifetime, and this allows returning references whose lifetime depends on the lifetime of the arguments. Yeah, so this is an example. So we have lifetime tick A. I don't know how to call that properly, but yeah. And then this has this variable has that lifetime, but then the returning value also have the same lifetime. So essentially means that return value depends on the lifetime of the num argument. Hopefully that's the right understanding. But yeah, let's see here. So number is n, and then we have a function, and we take a reference to n, but that means that v will have the same lifetime as n. So v borrows n immutably, thus v cannot outlive n. Exactly. So if n is going to be destroyed, or if n is reaching an end of a lifetime, then the v also will have an end, because it doesn't make sense otherwise. While v exists, n cannot be mutable, and the same in the other way around is also true. So while v is there, since we have immutable borrow to n cannot be borrowed, mutated, or moved. That's also legit. Okay. When there is a single input lifetime, it doesn't need to be named, and everything has the same lifetime. So the two functions below are equivalent. Okay, that's a little bit now scary, because essentially this means that implicitly, like every function that takes num and then returns a reference, probably the Rust compiler is, if I return here, I can't, if I return a reference, yeah, what happens if I have two variables? Let's actually test this. So my assumption is, what happens if I have two arguments and I return one reference, and then what's happening with the variable that's not used? Hopefully, let's test this somehow. Wrong keyboard. Just to switch caps. Okay. So what do I have here? I have that. I don't have anything here, but let's put here a function that takes this and number, let's say num1 is number and num2 is also number, and I return number1 value. Okay, so and now the question is, if I do let n1 equals num value, and 3, let's say I don't know, 1000 and 2, 32, 2000. Okay, if I have n1 and 2, which means, so I take immutably borrowed n1 and 2, and then if I take, let's say, sorry, what happens if I take mutable, so n3 let n4 equals mute, so I passed n1 and 2, n2 is not actually returned, n2. What's gonna happen here? I think that's the case that I want to test out. My bad, my bad. We have a number here. And what's number? Bool and okay. Okay. Seems I forgot a couple of things. Doesn't work like that. We are close here now. Expected name lifetime parameter. Okay. So in this case, we have to specify the lifetime. Yeah, that makes sense. That makes sense. That makes sense. So if we go back here, so what we have to do is, so thick, if I remember correctly, thick A. Let's do thick blah. Thick lifetime. We need only this is required. No. What's the lifetime? How to? Yeah, like this, and then at the end is also reference 32. Okay, because we are only the return value only depends on the first argument. So if we cannot borrow as mutable as it not declared as mutable. Okay, but if we do mutable, that's gonna fly. Okay, great. Okay. So in this case, n2 is just taken. Let me validate. N2 is taken as immutable borrow, but then that whole function is done, and here we can still take a mutable reference. But if we change lifetime n2 so if lifetime is not, let's say that that's it. Now we depend on the second argument. No, I'm doing something wrong. Number. Because I'm doing something wrong. Let's say mutable. N2 is mutable. I'm taking. Why is this okay? Have I done this correctly? So lifetime. Aha. So N3 depends on, what does it says here? While V exists, N cannot be mutably borrowed. But it can't either way because it's not. So if I remove this here, yeah. Now we have a bit more warnings. So if this is intentional prefix, it's not used, okay. Unused N3, okay. Unused N4, okay. No, that's cannot borrow N2 as mutable, as it is not declared as mutable. Yeah, this is different thing. So this can happen either way. So we N cannot be borrowed, mutated, moved. But I can try to move it. Not I can do this. This should be move. Number. If number has a copy and clone, let's just comment this for now. That's gonna fly because we have copy. Let's do number. Let's do just non-copy number, and now non-copy number. So this now shouldn't be possible. I'm sorry. What? So I've moved that. I'm doing something wrong, but I don't understand. So num2. What if I print dummy print and 2. Yeah, now I have to I need to have all these implementations. Can I do that somehow? Debug. This is gonna still fail because we don't have the display. Let's just copy this for now. Sorry, this is a bit boring because I want to, and I still don't know enough how to non-copy number. Should work now. Ah. We are close to the thing that I wanted to test. And 3 and 4. Yeah, okay, so N2, borrow of N2 occurs here. Move of N2 occurs here. Borrow later used here. Yeah, that's exactly. So it's working now because yeah, exactly what was the case. So N2, N3 depends on the lifetime of N2, and N2 is moved here, and then this fails. So doesn't make sense to do this. But yeah, it takes. Compiler is, if I understand correctly, compiler is smart enough if N3 is never used, it's gonna just ignore the whole thing. So if let's say if we comment this, yeah, it's just gonna pass and no problems will be detected, which actually makes sense because, like, why would you care about that? Even though you have that might be a problem during development because you later figure out you do a mistake and then compiler ignores that, and then later when you start using stuff, then errors occur and then you have a hard time debugging. But yeah, maybe this should be a warning or something. But yeah, it would probably take longer to compile to actually warn about these things. Okay, but let's just be complete and let's go back here and do this. If we depend on N1, this should be now this should be fine. Yep, great. I think I completely understand now, and we have actually an example of this. So let's just name that somehow lifetime. How to call that properly? Argument. Example. Okay. Makes sense. This is obviously so if you have a single, that's what confused me. So if you have a single argument, I think then Rust compiler is doing this implicitly. If I'm correct, I'm not 100% sure, but I would say that's the case. And otherwise, you have to specify these lifetimes. So Rust compiler is requiring you to do so. Okay, structs can also be generic over lifetimes. Yes, which allows them to hold references. Yep, so structures can also hold references. Yeah, and you have defined that in the same way. So yeah, if you have a lifetime template parameter here, you put it here, and that's the same. So that's the same as with functions. So the same behavior. I mean, equivalent behavior just for structs. The same code, but with an additional function. Yeah. So lifetime of that is depend. Yeah, this is just chaining now. So you have a function that has these lifetimes, and then the struct also has the same lifetime. So the same stuff, just one level deeper. Xref cannot outlive X. Yep, even though this is not returning like directly a reference to X, it's returning reference to this, not reference, this, the struct that has a reference. The same code, but with Eli, how is that pronounced? Let me actually check that. I can't hear. I can't hear here, but I can hear. Elided. The same code but with elided lifetimes. Whew. Okay. Lifetime, fine. And then we have a regular reference here, and then we do nothing here, and then that still has a reference to X. And now you have xref cannot outlive X. That's the same. What's the actual, why would someone do that? I actually don't understand now. Maybe again some default, since yeah, I don't like this implicit stuff, so it's not clear what is happening. Let's go a bit further, maybe we understand. Can be generic over lifetimes too. So implementation. So this is just the same thing, just with when you implement stuff. So implementation for that type of Memgraph. Okay, but you can elision to elide there too. Yeah, this elision probably means that you just save. This is just like a syntactic sure, I think, just to do less typing. Yeah, so we essentially here, yeah. So here, since you don't specify a lifetime here, you have to elide a lifetime here, because this struct accepts a lifetime. So you have to specify something, and then this means like a default stuff. Yeah, okay, this is just a bit less typing, but nothing. You could just put the same thing here, and yeah, then it's evident. Yeah, you can just remove that, and it will figure out that you have these lifetime dependencies. Yeah, these are all just shortcuts to do the same thing. Okay. There is a special lifetime named static, which is valid for the entire program's lifetime. Boom. This is something global. String literals are static. So static string person name, boom. But own strings are not static. Person static string. What are own strings? I have a reference person, boom. name is allocated here. This is a string, and it's not this, and then bomb. Since p let's actually test this just to be sure. we do these two lines. That should explode. Long enough requires the name is borrowed from static. Okay. If we do, now the example follows. So we have the lifetime. We have the lifetime of these as let's be concise with the example. If we do this, so that has the lifetime as the thing that goes in, and then okay, this should be now fine. Yeah, but again, okay, we need to interesting, since now we need a lesion of the lifetime. That's okay, so I'm stupid. So here we need a lesion of the lifetime, because doesn't matter for the display function what's the actual lifetime of that type. So the type should be elided here, and should all be fine. Sorry. Great. Okay. It makes total sense. So let's just go back here. So we had to I added debug here just to be compatible with dummy print method, and we have a lifetime for the string specified, and also here maybe to repeat this. So I was complaining about this lifetime lesion, but it's actually very useful here, because we have to implement display trait for the person, but for the implementation it doesn't matter what's the actual lifetime, so lifetime can be elided and should be elided, and then that's done by this. And yeah, that all now makes much more sense, and it works properly. Okay, or take ownership. Yeah, that's a regular way of doing things. This is nothing. This is default way. So person has a name, and then the name is moved here, and name can't be. I mean, lifetimes of P and name are not related in any way, but name shouldn't be used after P. Let's just test this just to be 100% sure what I'm speaking about. So person, we have that person which is, let's say, ref str person, ref str person, and then we have other person, derive debug. I don't know, maybe there is a shorter way of doing this, but I'll just avoid doing experimenting now because we might end up in completely different set of problems. Name string, and then doing this here. Let's just compact this a bit. Person doesn't have a lifetime now. This should be fine. So person, here we have ref str person, and let name so this name should be now moved, and if we dummy print P, should be fine, but if we dummy print name, that should explode. Yes. So this now should be fine. Okay, great. Makes sense. Speaking of structure, struct literal when a field is set to when with same name. Okay. Let's just use this. Yep. For types in Rust, there are owned and non-owned variants. Slices are reference to multiple contiguous elements. You can borrow a slice of a vector, for example. A vector? So this is a syntax for taking a slice of a vector, which is nice. The above is not magical, of course, as nothing, as everything else. Encoding the indexing operator is overloaded with the index and index mute traits. I won't play with this now. I think it's pretty straightforward. 0 is greater. Contains what is that now? So 0 or greater. This is some short syntax for a vector. Okay, let's ignore that for now. I think this is just only, yeah, 3, 4, 5. But what's the type of that? So this is not evident. Type, maybe a type. Print type name. Print type name from 1 to 5. What's gonna happen here? This is a range. This is a special type. Okay. Okay. And why do we need and here? Probably because that's a range, and then no idea. But okay. Let's skip that for now. Borrowing rules apply to slices. Okay. A tail. We take a tail of that. Okay. Lifetime again. Lifetime of the X. Yeah, that's all legit. So lifetime of Y depends on X. Yeah, I'm using that depends wording, but I think that's correct as well. That should be equivalent. Because it essentially, this means that these two lifetimes are coupled together now, and yeah, it has a couple of implications. So the one cannot outlive other, and etc. This is the same. This is legal. So y let x is now a ref. Tail depends on x. Yeah, that's exactly. So if this hadn't been a static array, it wouldn't be possible to do this, because this lives for the entire lifetime of the program, because it's static array implicitly again. So if you change this, then this is dynamically allocated, and then everything goes to crap very fast. Okay, because a vector is heap allocated and it's a non-static. Yeah, values are really slices. Name. str name split lost. This does not create a new string, it returns a slice of the argument. These reference strings are also slices. That's important to know. Yeah, because otherwise you would have a copy of the whole thing, and then it would be more safe, but it has more memory overhead, because you would return whole strings. I mean, you would make a copy and then return a reference, which doesn't make much sense. Okay. Let some ext. And we are returning option Yeah, makes sense. Borrowing rules, yeah, it's gonna fail because this string is now dynamically allocated. And it's not good for these type of things. Yeah, okay. Function that can typically return a result. That can fail. What? Okay, this is obviously a watermelon UTF character. And okay. This is obviously something wrong, and then nothing is returned in S. And then this is, or error is, no, error is here. Result has an error. And yeah, unwrap, blah, blah, okay. So yeah, unwrap is called here to go to panic if something is bad here. So this is obviously something wrong with UTF-8. I'm not sure exactly, but yeah, it's not a UTF character. Expect for a custom message. This is the same, but you get exactly this message out of the when there is an error. Or you can use match. Yeah, okay, then okay. On error S, on panic E. Or you can E-flat okay, yeah, the same thing. These are all syntax that we already mentioned, so I won't now repeat this. You can bubble up the error. Okay. If there is an error, you can, instead of panicking, you can return an error here. So result has something, I think that character, or what is the type of, I think string or something. Why do we don't have string here? Maybe this is some kind of illusion as well. Let's actually try this out. So, but we're gonna do that in another function. So function, let's say UTF-8, UTF-8, UTF-8. Returns result and This is actually interesting. So this is matching stuff here and then returning error if that's the case, but OK somehow understands what is here. That's gonna magically fail. Maybe not. It returns nothing here. Wow, boom, we got a nice character here. Okay, but what if that result returns nothing? Okay, returns like empty stuff. But if we do error, this is an error. Error is returned. So this is redundant here, just another, sorry, off topic, but yeah, we don't need this here because there we needed these parentheses because of the priority of operators, I think, but here they are not required. Error. What's the result dot? Nope. No, this is different. How to print? Sorry. Let's do match result. If okay s. So essentially we want this just on the different level. So if result is okay, then print s. If it's not okay, then print e. Why not? Because it's empty. But why I have no. If okay, printf is why I have aha, sorry, if this return s, I think I'm getting into the rabbit hole. Here, because we have result which is now this is gonna probably fail. Expected result found. No. If OK od s, OK od s from OK from s. Found. So expected struct string found reference. Yeah. If we do here ref str, I have a reference to that string. Boom. This function return. Now we have a lifetime thing named lifetime parameter. If we do static here, it should actually panic because we have a wrong character, but if we do this, that should return our watermelon. Haha. Okay, great. So yeah, this is correct now. Yep. All good. Let OKS, that's okay. You can bubble up the error, yeah. You can use to do the concise. This is actually the question mark here is replacement for all these match okay type of thing. Really? How does he know about... no, it's not for everything. It's just for print. It's actually, I think the question mark here is actually replacement for what I wrote for this. No, for this. So replacement for that whole function. So let's try it out. So if I replace hard-coded example with this, I should be able to have the same code. So Boom. Cannot use operator in a function that returns this is actually the question mark operator can only be used in a function that returns result or option. But yeah, from UTF-8 returns result. Yep, returns result. No. I'm doing something wrong. Aha. Yeah. This is actually dependent. Where do you call that? Oh, right. So we have to return some kind of yeah. So yeah. It's not the same. Okay, I understand. So we have to return some kind of a result if we call if we put that question mark here. So let's just fn hard-coded UTF example short. Let's just return. Okay. Result this static str std str UTF-8 error, and then let so do this, because yeah, this will expand into return, and then return will be let this, and then we print. But if an error, that's gonna be returned as an error, but otherwise we just do OKS, and that's it. Hard-coded example short, and then here we do this. I think this should work now. Yep. Okay. Yeah. Okay. So yeah, the question mark here has to be called in a function that returns result or option. Interesting. Yeah, my overall feeling is that Rust is having a bunch of these implicit stuff, which are kind of nice, because if you know them, you can save a lot of time typing stuff. Okay, the star operator can be used to dereference, but you don't need to do that access field or call methods. Pref. Okay, that's the same apply. The same is valid in C++. So yeah, I understand that. If you have a reference, you can access functions or fields just by the dot syntax, and you can only do it if the type is. And you can only do it if the type is copy. Point negative ref pref cannot move out of okay. Yeah. Point. Cannot move out of. Aha. Since this is a reference, we cannot by default move this. Aha. Yeah, makes sense. So if we do this, that point has a copy. Yeah, this is gonna do a copy here. There's a copy of point, and then that's gonna be moved into negate. Closures are just functions of type fn, fnmut, or fn1s with some captured context. Okay. These parameters are a comma separate list of names within a pair of pipes. You don't need curly braces unless you want to have multiple statements. Okay. So for each planet, function where fn static string. Okay. La 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 la. And then we can just planet will be moved. No, sorry. Planet is a capture print planet for each planet. So for each planet, yeah, this is a lambda function. So this is just the first argument here. That's it. The borrow rules apply to them too. Okay. For each planet, greeting planet closure. So it captures good to see you. Greeting is taken from here. I think at the moment of calling, and then planet is just this 3 here. F must have static lifetime. Closure may outlive the current function, but it borrows greeting which is owned by the current function. Closure may outlive. let greeting move planet. Greeting is no longer borrowed. Borrowed is moved. But by default, what by default these things are borrowed. Why we don't have X and here? Not sure. Sure. Okay. And fn mut needs to be mutable. ff2 x times 2, so times 2 times 2. Okay, this is not where f mut I32 returns cannot borrow s as mutable more than once. Yeah, so okay, cannot be mutably borrowed multiple times. Mute f, this is legal again. Tmp f mute f tmp. This is legal. Okay, you can borrow multiple times. This isn't mut f. This is now, I think 2 is copied into TMP, and then interesting. This is interesting. I think this is the case. So this is TMP is copied here, and then that can be moved here. Closures mutably borrow local variables. Fn mut E32. Accumulator is 2, and then you take accumulator, you add 1, and then you multiply. But accumulator is mutable, and it has to be it has to be marked with mute. Cannot be passed to functions expecting. These closures cannot be. Okay. Cannot assign ACC as it is a captured variable in a fn closure. The compiler suggests chaining foobar to accept closures that implement fn mut. Mute. Fn once closures can only be called once. They exist because some closure move out variables that have been moved when captured. Okay, fn once, f can be called once. Move, this moves, so nothing is passed here. So yeah, this is a bit strange. My comment in general is that where is that here? So these are the actual arguments, lambda arguments, and these are captures. I mean, the greeting is capture. So this is a bit interesting syntax. Okay, these closures can be passed to functions expecting fn. Okay, this that's something else. nothing is here. We have S. S was moved into our closure, and our closure moves it to the caller. F. Aha. Foobar moves S. S. This is a capture. Our closures move. Where is it returned? Remember that string is not copy. String is not copy. This is also returning. So lambda is returning S, and then it's moved once here. And then so we have like two moves here, like once in this instance, and then when the function is actually called, and then you have two moves, and you shouldn't be after here, you shouldn't do that again. Use sorry, yeah, makes sense. I won't play with all of this, so I think I understand good enough. And yeah, if there is something unclear, feel free to ask. If you need convincing that our closure does move S, this is illegal too. Okay. Yeah. That's fine. But this is fine. Yeah, cloning is fine because clones are moved. Here is closure with two arguments, x, y, foobar function is greater. It accepts two arguments, where f is taking two arguments, greater, smaller, if yeah, okay. If you ignore panic, here is closure ignoring both its arguments. Okay. Count tick f u size unsigned size. Okay, for I in 1 equals count ref tick countdown 3, call I, print ln tick I tick 3 2 1. So we are going in reverse order. What is this? Yeah, why we need this is interesting. I'll test this. I don't understand here. So So I don't understand the equal sign here. I'll just make a compiler to scream. Aha. Aha. Okay. This is again special syntax. So I think equal here means from 1 to exact that number to 3. Otherwise, it would be it's 1, 2, it's 1, it's count minus 1 inclusive. So yeah, all good. So if we do here count, now it will be up to 3. Yeah, okay. Makes sense. Also logical. And here is a toilet closure. So flump. Really? What's that about? If we do here, this is doing nothing, so it's gonna be ignored. And yeah, we just seen a range being used, but this also works with avec. Yeah, okay, that's a range, a slice. All right, so this is dynamically allocated, this is fixed. Iterator node str also has a bytes iterator. Raster types, okay. Even mapped and okay. Lowercase. So C is uppercase. He's okay. Is ASCII alphabetic? Okay. Flat map. Flat map will just turn that into a string. Or no. No. It just prints that. What does flat map do? I think that should be pretty straightforward. Just returns an iterator to that. Yeah, okay, basic. Okay, iterator to that, which is lowercase, and that's it. You can return closure from a function. Challenge equals answer. That returns dynamically allocated string, which is moved into that function, and then that function test if, and it returns a closure, and the closure will test if these two are equal. Okay, makes sense. Let me just the move here. So the move says that, if I understand correctly, the move says that these captures are moved. Yeah, moved into the closure. And that refers to the greeting. Okay, but here we don't have any argument. Move. Why do we need move here? Let's test. I really need to fix the formatter, but okay. Make tester. Let's test exactly this. False true. What if we do this? Closure may outlive its current function, but it borrows answer. Ah, it doesn't matter where you put. Aha, okay. So yeah, it answer is borrowed here, but if we put move here, the answer will be moved into that closure, which is okay. But yeah, I really like these compiler warnings, because like even if you don't understand something, compiler will explain you exactly what is going on. I really like that. It's a really nice. Okay. Move challenge, la. Okay. Or with elided lifetimes. Impel. You can even move a reference to some of the function. This is now second example. I skipped one. So if I take I have a lifetime A, and then answer has a lifetime, and then the lambda, this is apparently the syntax for lifetime for the bool. What is actually, no, I don't understand this part. Return value, why the return value, that return value also has a lifetime apparently, and then you can even move a reference to some. Answer is now a reference. answer is now a reference. What's gonna happen in this case? Uh, Sorry, I'm a bit too fast. Okay, that should work, but what I'm curious about, what's gonna happen if I remove that lifetime? Because it's like bool value, why we need a lifetime for that? Boom. This data has a lifetime A. Good. Is captured here. Answer is captured. All right. And it's taken, and it's, so basically that's a reference. And then, and is required to live as long as static here. To declare that capture data from organization, you can add an explicit isolate bound. That's like the syntax for captured is here, and you need to be explicit about the lifetime of that return value. Yeah, makes sense. A lifetime A, or other way around, if you elide, so you don't need to specify this at all, string function string bool. But interesting, if I leave, if I remove this, what's gonna be the error message in that case? This data with an anonymous lifetime. Okay, anonymous lifetime is captured here, and it's required to live as long as static here. 181. Function. This is very interesting because obviously functions have lifetime static property, and since the answer is, I mean, the closure within make tester ref is capturing answer, that return value also has to have the same lifetime. And yeah, that's why we need to say, and this is bool plus that anonymous lifetime is the syntax to do that. So yeah, very nice. Okay, great. I'll leave that as that. Oh yeah, great success. We finally reach an end after what's the time now? I'm already doing 2 hours. Yeah, almost 2 hours. So yeah, it didn't take 30 minutes. It took actually 5 hours to go through all these examples. I mean, I didn't just read everything. I was playing around with all these examples and really tried to understand everything. So, and I'm very glad that I actually did this, because now everything is much more like clear to me. I hopefully you also learn some stuff. And yeah, if I would have to emphasize one thing about the whole experience, probably the biggest thing is the Rust compiler and these error messages. That's really amazing. So it's really just by playing with the compiler, you can learn a bunch of stuff. I mean, that's obviously the case with other programming languages as well, but here these error messages are really amazing. Okay, that's it for today. I already spent 2 hours, so I won't do anything else today. But yeah, next time again, hopefully I'm gonna start doing some real stuff with query modules. I think now I understand enough of Rust to actually do something productive there. Maybe I'll throughout the week I'll read some of the other tutorials, but I'll try to be productive next Saturday. So yeah, that's more or less it. Enjoy the rest of the weekend. Please subscribe and like if you like this content. And yeah, see you next Saturday. Bye bye.